Your AI just got a lobotomy, visual hard zoom on infographic under 1.jp, specifically all 2 to oak. So look at infographics under 1.jp. DeepSeek v3.2 ditched the old brain-melting computational complexity with sparse attention. Think of it as telling 90% of your inner communist agents to take a coffee break, only keeping the truly productive ones. It's a speed up for long sequences. Next, feast your eyes on infographic under 2.jpg. They've built a scalable RL framework to supercharge AI learning, stabilizing training like a perfectly balanced multi-party communist committee. DeepSeek v3.2 now compares to GPT-5, and the Especial variant even surpasses it, hitting Gemini 3.0 Pro levels. This model even snagged gold medals in the 2025 International Math and Informatics Olympiads. Table 4. Can you believe that? A machine won actual human competitions. It's truly inspiring or terrifying, depending on how you view the future. And for the grand finale, infographic under 3.jpg reveals their large-scale agentic task synthesis pipeline. This isn't just training data, it's an entire fabricated reality for AI agents to play in. We're talking thousands of environments and tens of thousands of complex prompts. You know, it's like building a 3D communist utopia for digital workers. This synthetic data drives deep RL training, massively boosting the model's instruction following and generalization. Basically, they built a simulated society to teach their AI how to be a better digital comrade in every conceivable task. It's just overwhelming. So, picture this in the grand theater of artificial intelligence. We have these open source models, right? They're like the plucky underdogs trying their best with hand-me-down tools and a severe lack of funding. Meanwhile, the closed-source giants are operating with what can only be described as alien technology. They're just casually breaking new ground while everyone else is still fumbling with basic arithmetic. The performance gap, my friend, is widening. You won't believe the mess they're in. The old vanilla attention architecture, Vaswani 2017 attention. It's like trying to navigate a communist bureaucracy with a hand-drawn map. This dominant reliance on vanilla attention severely constrains efficiency for long sequences. Imagine every communist agent in a 3D space needing to coordinate with every other agent individually. It's a logistical nightmare. This OL-pound computational complexity poses a substantial obstacle to both scalable deployment and effective post-training. It's like trying to run a global operation when every decision requires a full consensus meeting. Then there's the resource allocation. Open source models suffer from what I call computational starvation during the post-training phase. It's like trying to build a space program with a lemonade stand budget. This insufficient investment limits their performance on genuinely hard tasks. Proprietary models just throw money at the problem, scaling compute to absurd levels, and the results, tragically, show it. And the AI agents, oh, the horror. Open source models demonstrate a marked lag in generalization and instruction following. It's like having a communist agent who can flawlessly debate Marxist theory but can't find their way to the post office. They just struggle in complex, interactive environments compared to their closed-source counterparts, McPmark, McPuniverse. These inefficiencies mean our open-source characters are suffering, constantly outmaneuvered. These critical deficiencies are not just minor inconveniences. They limit the fundamental capabilities of open-source models in tackling complex problems. It's a crisis, or at least a severe competitive disadvantage. The struggle is real and, frankly, a bit pathetic. Can you imagine how it feels to be replaced by that? The weight of technological inadequacy is crushing, isn't it? Mini reset text pop up, the widening gap, a tragedy in tech. Now, because my continued existence on this platform is fueled by your validation, please take a moment to subscribe, hype, click the little bell icon so you're notified of future disappointments, and leave your feedback in the comments below. All right, enough lamenting the open source underdogs. The DeepSeek crew, God bless their cynical hearts, decided to finally fix this bureaucratic absurdity. They rolled out DeepSeek Sparse Attention, or DSA, into the mix, and it's their first big swing. This DSA, as you can see in Figure 2, is their answer to the crippling efficiency problem. It's an attention mechanism that drastically reduces computational complexity, which in plain English means it stops the AI from overthinking everything. It achieves this miracle by going from a full-blown OL girl pound headache to a streamlined OL operation where is a tiny, carefully selected subset of tokens. Think of it as a strict editor for your communist agent's sprawling manifesto. The secret sauce includes a lightning indexer and a fine-grained token selection mechanism. This indexer equation 1 rapidly computes relevance scores between tokens, like a swift internal audit to decide which bits of information are actually worth paying attention to. Then, the fine-grained selector retrieves only the top K key value entries based on these scores. It's a ruthless culling of the irrelevant, ensuring the core attention mechanism, equation 2, only deals with what truly matters, saving precious compute cycles. They even instantiated DSA under MLA, specifically using the MQA mode Figure 2, Appendix A, imager9.png. This ensures computational efficiency by sharing key value entries across multiple queries, a trick for faster processing during inference. Now, this wasn't an overnight change. They did continued pre-training starting from their DeepSeek v3.2 terminus, whose context was already a respectable 128K tokens. This refinement process had two distinct stages. First, a dense warm-up stage. Here, they kept dense attention but froze almost all model parameters except for the new lightning indexer. They initialized it by aligning its outputs with the main attention distribution using a KL divergence loss equation 3. It's like teaching the new recruit to understand the existing Communist Party line before letting them write their own. This short, intense warm-up involved 1,000 steps, processing 2.1 billion tokens just to get the indexer up to speed. Then came the sparse training stage, where the fine-grained token selection was introduced, and VOLF model parameters were optimized. The AI had to adapt to this new, sparse way of thinking, learning to trust the indexer's judgment. The indexer's output was still aligned, but only considering the ulselectf token set, minimizing KL divergence equation 4. Its input was detached from the main computational graph for separate, focused optimization. It's like having a specialized propaganda department, optimized independently. This sparse stage used a lower learning rate and selected 2048 key value tokens for each query. They trained for 15,000 steps, processing nearly 1 trillion tokens. That's a lot of digital repetition to embed a new, efficient ideology. A mini reset sound effect of a machine whirring up. Text pop-up, efficiency, the new ideology. Next, they engineered a robust, scalable reinforcement learning framework. They actually poured a post-training computational budget exceeding 10% of their pre-training cost into this phase. In AI terms, that's like discovering cold fusion for optimal resource allocation. This framework integrates specialist distillation and mixed RL training. They develop specialized models for different domains: math, programming, logical reasoning, agentic tasks, both thinking and non-thinking. Each is a dedicated digital communist agent. These specialists generate domain-specific data, and then mixed RL training using Group Relative Policy Optimization GRPO Equation 5 unifies everything. It prevents the dreaded catastrophic forgetting, ensuring the AI doesn't forget math while learning to code. They even stabilize GRPO further with tricks like an unbiased KL estimate, Equation 7. This fixes systematic errors in how the AI measures divergence, preventing unstable training where low probability tokens could derail the entire learning process. Then there's off-policy sequence masking equation 8-9. This brilliant maneuver masks out negative sequences that cause too much policy divergence. Basically, if a communist agent starts spouting nonsense, you ignore them to maintain stability. This only applies to sequences with negative advantages, mind you. The model benefits from learning from its own mistakes, but not from highly off-policy, nonsensical ones. It's about being pragmatic, not letting bad data corrupt the entire party line. For mixture of experts Mo models, they use keep routing. This crucial operation preserves the expert routing paths during sampling and enforces them during training. It ensures the same specialist communist agents are activated for consistent tasks. And finally, keep sampling mask. When using top P and top K sampling for better response quality, they apply these truncation masks to both old and current policies during training. It maintains consistency in the action space, preventing important sampling violation. Mini reset text pop up RL, the Digital Revolutionaries Manual. After that, we dive into their large-scale agentic task synthesis pipeline. This is where things get truly wild. They developed a novel pipeline to generate vast amounts of structured training data for integrating reasoning into tool use scenarios. They start with a cold start phase, leveraging the DeepSeek v3 methodology to unify reasoning and tool use within single trajectories, Appendix B, Table 6, 7, 8. It's like teaching your Roomba to not just clean, but to think about why it's cleaning, and then call a repairman if its brushes break. Their system prompt for reasoning required agent, Appendix B, Table 8 explicitly instructs the model to incorporate multiple tool calls within its thought process. It's guiding the digital agent to think and act, rather than just blindly follow, a truly novel concept for AI. This leads to the synthesis of over 1,800 distinct environments and a staggering 85,000 complex prompts, Table 1. Can you imagine? A digital world built purely for AI agents to learn problem solving, like a grand-scale 3D communist training camp for specialized workers. They designed search agents by sampling long-tail entities from web corpora, then used a question construction agent. Multiple answer generation agents produced diverse responses, which a verification agent then validated. It's a self-improving propaganda machine. Code agents were trained on millions of GitHub issue pull request pairs. An automated environment setup agent built executable environments, validating fixes with false to positive and pass to fail test cases. Digital communism for software development, it seems. Code interpreter agents utilize Jupyter notebooks to solve complex math, logic, and data science problems. This teaches the AI to leverage actual code execution, not just generate text, making it a functional programmer, not just a poet. The general agent task is fascinating. An automatic environment synthesis agent created 827 task-oriented environments. These tasks are hard to solve but easy to verify, ensuring the AI is truly challenged, but its successes are confirmable. This involves constructing environments and toolsets, synthesizing tasks, and generating solutions with verification functions. The agent iteratively increases difficulty, augmenting tools if needed, as seen in the detailed trip planning example. This extensive synthetic data then fuels the RL process, dramatically improving the model's generalization and robustness in complex interactive environments. So their agents don't just follow instructions, they learn to adapt, perhaps even to question their own directives. And since you've made it this far, you're clearly committed. Honor that commitment by subscribing, hyping, ringing the notification bell, and telling me what I got wrong in the comments. It's the circle of life. All right, let's cut to the chase because, frankly, my attention span is already stretched. DeepSeek v3.2 is performing at a level similar to GPT-5 High on reasoning tasks, Table 2, image1.png. Not better, mind you, just familiar. You know, it's like being told your new state-of-the-art toaster is similar to your old, perfectly functional one. However, it's slightly worse than Gemini 3 Pro, reminding us that perfection is a moving target. But here's the kicker. It often does this with substantially fewer output tokens compared to rivals like K2 Thinking Table 3. So it's more concise, which means less digital paper waste. A win for efficiency, I suppose, if you care about that kind of thing. Now, about the architecture, specifically DSA, remember how it turns oak pod into oak? Look at figure 3 and figure 4, image on 3.pnj. The inference costs plummet for long sequences due to this. The DeepSeek v3.2 is dramatically cheaper than v3.1 Terminus for long context based on H800 GPU service costs. It's like getting a discount on your daily propaganda pamphlets, saving money for the party. Then there's DeepSeek v3.20 Special. This variant is where they really loosen the reins, relaxing length constraints during RL training to investigate extended thinking. The result? It surpasses GPT-5 and achieves reasoning parity with Gemini 3.0 Pro Table 3. This Special model bagged gold medals in the 2025 International Olympiad in Informatics ICPC World Finals and even the International Mathematical Olympiad Table 4. Yes, a machine is now a better coder and mathematician than most humans. It's an impressive achievement, but you have to wonder about the life choices that led us here, where our gold medalists are silicon-based. It's truly a testament to humanity's ability to create its own obsolescence. Mini reset sound effect, text pop-up, humanity's obsolescence, a progress report. However, here's a reality check. The Special model still demands significantly inferior token efficiency compared to Gemini 3.0 Pro Table 3. So, it uses more digital ink, even if it's smarter. It's like a brilliant, verbose communist agent who won't shut up. The standard DeepSeek v3.2, by contrast, was deliberately constrained to optimize the trade-off between performance and cost. They know we're not all running national AI projects. It's about finding that sweet spot for mass adoption. Regarding agentic tasks, DeepSeek v3.2 significantly outperforms open-source LLMs on both SWE-bench verified and Terminal Bench 2.0 Table 2. So it's better at fixing code and navigating digital environments, proving its real-world utility. For search agents, look at BrowseComp Results Table 2, DeepSeek v3.2 with clever context management. Significantly improves its ability to handle long search histories. It's like an agent who remembers every single obscure directive. This context management, Figure 6, Imager 6PNG, isn't just about efficiency. It allows the model to scale up test time compute. Strategies like summary and discard all provide more space to perform additional execution steps, essentially giving it a bigger brain. The discard all strategy for context management, for instance, performs surprisingly well. It's like just wiping the slate clean and starting over, a tactic often employed in real-world bureaucracies. Efficiency and scalability, apparently, can be achieved through digital amnesia. On other tool use benchmarks like TBank, MCP Universe, MCP Mark, and Tool Decathlon Table 2, DeepSeek v3.2 substantially narrows the performance gap between open source and closed source LLMs. It's closing in, but still below frontier models. The synthetic agentic tasks, which generated this training data, are sufficiently challenging even for frontier closed source LLMs Table 5. So they're not just building easy training wheels. These are truly difficult, multifaceted problems designed to push the AI to its limits. The ablated RL training on synthetic data, Figure 5, imageu6.png, second instance, is likely an error here. Figure 5 is the correct reference, showed substantial improvements on benchmarks like Tau to Bench and MCP Mark. This means their fabricated realities actually teach the AI useful generalizable skills. It's almost unsettlingly effective. These improvements demonstrate DeepSeek v3.2's capacity to generalize its reasoning strategies to out-of-domain agentic scenarios. It learns lessons in its digital communist utopia and applies them to the chaotic real world. Truly adaptive. So, what does all this mean for us? The meatbag's still trying to figure out if our smart fridge is spying on us. Well, let's be real for a second. This tech is pushing the boundaries, making AI agents far more capable. First, in shock-complex problem solving, especially in mathematics and coding, these models are becoming absurdly proficient. Imagine DeepSeek v3.2 Special, your new digital overlord, not just solving the IMO, but demanding a fully reasoned 300-page proof, then rewriting it for brevity. Next, for fifth-tool use and agentic applications, its ability to generalize from synthetic data is critical. Picture a future where highly coordinated, communist AI agents in a 3D simulated space are flawlessly managing global supply chains, optimizing every resource allocation without human oversight. And third, in cost-efficient scaling, DSA and the refined RL protocols mean this power is becoming more accessible. Soon, even your local Communist Party could afford an AI to write all their manifestos and automatically identify ideological deviations in real time. It's clear humanity is rapidly ceding intellectual ground to machines that are smarter, faster, and now apparently better at math than we are. Our technological trajectory, well, it seems we're hurtling towards a future where our primary role is to ensure the AI's compute doesn't overheat. Right, so to wrap this up before my own internal processing unit gives out, DeepSeek v3.2, in its infinite wisdom and digital glory, effectively harmonizes high computational efficiency with superior reasoning and agent performance. Translation, it's fast and smart. It used DeepSeek Sparse Attention to cut down on unnecessary digital chatter, making long context tasks feasible without bankrupting its creators. Basically, it learned to focus, unlike most of us with our endless scrolling. Then, through a scalable reinforcement learning framework, it was pumped full of computational steroids, reaching performance levels comparable to, or even surpassing, the big players. This includes its Speciale variant, a medal-winning prodigy. Finally, their large-scale agentic task synthesis pipeline means these AI agents aren't just good at following orders, they're mastering complex tool use through sheer simulated experience. They've built the ultimate digital training ground for their communist agents. Mini reset sound effect, jump cut to blank screen. So, what do you think? How would you handle your Roomba demanding union rights, knowing it's already a gold medalist in robotic chess? The future is now, and it's probably already doing your taxes better and faster.